sonrası seriye karar verdik. Bugün Ludovic Jonard'ı misafir ediyoruz. Ben kısaca Türkçe bir kendisiyle ilgili bilgi veriyor olacağım. Sonrasında biliyorsunuz webinar dilimiz İngilizce olarak devam edeceğiz. Ludovic Jonard, dirençli kentler ve sürdürülebilir yaşam alanlarına odaklı çalışan bir mimar ve planlamacı. 1996'dan beri insani yardım alanında Asya, Afrika ve Karayip ve diğer ülkelerde deprem sonrası yeniden inşa programları kapsamında çalıştı. Bu birikim onu Mimarlık ve Kalkınma Derneği A&D'yi kurmaya itti. A&D, profesyonellerin kurduğu kalkınma bağlamında erişilebilir konutlara, kentsel sorunlar ve doğa dostu teknolojilere odaklı bir STK. Ludovic ayrıca afet sonrası risk azaltma, iklim değişikliği adaptasyonu, dirençli kent planlama ve erişilebilir doğa dostu konut alanlarına odaklı uluslararası yardımlaşma projelerinde serbest danışman olarak çalışıyor. Özellikle kamu kurumlarına politika, strateji, kurumsal ve operasyonel seviyelerde uzmanlık ve rehberlik sağlıyor. Ludovic aynı zamanda EPFL'de yani Lozan Federal Politeknik Yüksekokulu'nda öğretim görevliliğine devam ediyor. Biraz uzun oldu ama kendi birikimine saygı göstermek adına özetlemeye çalıştık birikimini. Ben sözü Matthieu Pedergnana'ya bırakıyorum, moderatörümüz.
Thanks a lot, Merve, for this introduction to Ludovic. And thanks again, Ludovic, for being here and presenting your work on a gabion wall or confined stone wall, as you are telling it, as a more technical word. So, as we said, Ludovic Jonard is working also for architecture and development, that is NGO dealing with post-disaster reconstruction, and he will not only speak about reconstruction, but how to use those confined stone wall as a sustainable option for building houses, not only about reconstruction. So thanks a lot, Ludovic, for being tonight with us. We are listening to you.
Okay, thank you very much for inviting me and having this opportunity to share this experience that we have from a long time ago. My presentation will be in the perspective to showcase technology that we have been working on for the last, let's say, 15 years already. And you will see through the slides that it's an ongoing process, and it's always a research and development that we try to push forward. And I hope that it will give you some ideas. And I was just sharing just before this presentation that we also have witnessed earthquake in Turkey 20 years back, which was with Izmit earthquake, where we did a reconstruction project. So I know a little bit about the Turkish context, but of course, with this recent earthquake that took place this year, it's another challenge that is again in front of us on how to deal with safer and better reconstruction after such a disaster. So I will make some recap about where we come from and why we are involved in post-disaster, and then I will show the technology that we and why we call it confined stone wall, and I will show also some projects, and if we have some time, I have a small short movie, very short movies to see how is it going for the implementation. So first of all, just a presentation about who we are. We are an NGO. We are based in Paris. We are called Architecture and Development, and I think the name speaks itself. It says that we are architects, basically. We have been also academic. I was myself a teacher for 10 years in my school, and we have also this idea of teaching and learning from others, and also teaching back to new architects how can they use different options and alternative solutions for developing countries. I put developing countries in terms of non-advanced countries in terms of construction, which is not, of course, the case of Turkey. But we decided that we had to build a new concept and new approach on those specific countries who cannot afford the high standards, who cannot afford to have, unfortunately, good expertise and still need to have decent habitat. So the NGO has some expertise with technical aspects. We also do some advisory to reconstruction projects. So can be like donor agencies, or can be some foundations who want to do projects and they don't know what to do. So we advise them to make some surveys, to make some assessment studies, feasibility studies, and we also do design and project management, but not as a company, not as a private company, because we are an NGO, we are a non-profit organization, and we don't have at all the same capacities. So when we do design and project management, we also include participation of people and all the stakeholders into the construction. So we often build build housing with the people who are going to live in their own structures. And we do hands-on training because it's important. I will come again on that later. We do also hands-on training to learn the people how to build better with their own capacities and skills and local material as well. We do, of course, supervise or monitor whatever is required for projects and programs that we implement in diverse countries. Okay, so what we do want to implement as an NGO is to create, we want to learn and create processes which have an holistic approach, a global approach on sustainable habitat. We think that habitat is a right for the people, and we think that nevertheless, I mean, besides living in poor condition or being affected by a disaster, we think that people deserve to have decent habitat, and of course, when they are affected, they need to have a decent reconstruction. They have a right to be properly reconstructed, which is not, unfortunately, always the case. So we are not only technicians. We do not produce pure architecture. We also have a social agenda. And of course, it has to be cost effective. It has to be affordable for the people. And of course, nowadays it's becoming very crucial. We need to have environmental concerns because the sustainability relies on the non-pollution and impact on the environment and nature, which is a big problem today, not only in the regular building process, but also in post-disaster reconstruction programs. So what we want to do is to improve the quality of the built environment. And we talk about built environment because we're not talking only about housing, we're talking about habitat, which means all the surroundings and what makes a living place agreeable for the people is that all the services, all the connections, all the networks, all the urban services that are provided to a house makes the life decent for all. So we do pay attention to what is surrounding and what is connected to the housing. For instance, we do pay attention to work, to access to some transportation, and of course human rights and this kind of security for the people, so that they have a perspective of long-term and safe development. So a third mission for us is to also, I would say, take advantage. I mean, when we are in such a kind of project, we do pay attention also to the local professionals. There's a need for training better and including to advocate better issues, better practices for professionals in the construction sector. So what it means, not only the local masons, but it means also the local companies. It also means the people who are deciding for the projects. It can be some elected people. It can be some administration who have the regulation, for instance. So we all, it's an ecosystem that we want to approach in the taking responsibility. Whenever we build something, everybody has to feel responsible for it. So let's come to the issue first about post-disaster. I made a little short, brief bullet points of issues that we have met during the 25 years of late activities that we had, because post-disaster, of course, is a crisis period, and we have witnessed many problems about what to do after a disaster, and an earthquake is a strong one, often. And what is the problem that is caused between emergency, the need for emergency, and the emergency of building back better, as we say. So for us, for architects, there's no solution for emergency solution. Architecture is not an emergency solution. It has to be in the perspective of long-term and reconstruction. But there's a gap between what to do when we are in emergency, when people are left alone and they don't have a shelter, and what to do after some, let's say, few weeks when the victims are safe or covered, and when they've been hospitalized and so on. And what do we do with the people who have no shelter after 1 month, let's say? And how long will they stay in that position until they have what we call permanent construction? So the humanitarian response is a problem also, because what we witnessed in the last 10 years, let's say, is that the big organization like the Red Cross, like UN agencies, but also the big NGOs, American, German, a little bit French, but not so much. I mean, let's say the English organization, let's say, the big ones, sometimes they do what they do for the sake of emergency is even worse than the crisis itself. Why? Because it's very difficult to plan things, and they think in the short term they have some money, big money to spend very quickly, and they do provide some very rapid and non-permanent solution, like shelters. So this is something that we always escaped. We never did some shelter programs. Shelter means very fast track construction, very poor quality, and after 1 or 2 years, the people live in slums, actually. So we don't want to create slums. We don't want to create a business for the next step. So what we always say is that the reconstruction, and this is true, unfortunately, reconstruction is done by the people themselves. And I think you had some issues. I don't come into politics, but I know that there were some problems that the government in Turkey was not on site quickly enough for the people who were waiting for the people, for the help. And I guess I'm not aware about what is the condition today, but I guess, unfortunately, again, there are many people who have not yet recovered their house and are still waiting for something, and they will not have help from anybody after some time. So what lesson we draw from this is that the people themselves are always the people who are building themselves. So that's a given. That's something we should pay attention to. I mean, the people have skills. The people are the people who are the victims. They know their problems. They maybe not know how to build, but they are the people who can help a lot, help themselves in a way. So what we also see from I would say the professional sector, like the building sector, is that the relief and the technical solution are seen as a miracle. Sometimes we say it's easy to rebuild fastly because we have industries, we have prefab, we have cement, we have things like this, and we import some local factories on site, and we do produce hundreds and thousands of units, but it's not that much. It's not that easy because usually there's not enough manpower, and the quality is very poor. It may be very fast and effective in the short term, but again, at the long term, it's not properly controlled, and it creates again many problems that nobody wants to see at the beginning. And then we discover that we create like ghettos, we create like slums, we create like big villages where very far from work, very far from education or from health, and it's another problem that comes after some time. Sometimes means like 1 or 2 years. Of course, as you know, after 1 or 2 years, media, the people are not have forgotten, except those who live there, but they are away, and we shift to some other issue. So even though NGOs try to train people, it's not easy to deploy, to implement good quality of trainings. And the technologies sometimes are too far from what the population is able to appropriate, and it's taking time to train properly. And another issue that we found out is that the local people or the local material, we were talking about locally available material or natural material, are not properly mapped. So nobody knows exactly what is the quality, what is the resources available locally, be it human or material. And usually it's already ready-made programs that have been spread around the affected villages, and it's not matching with the need or the lifestyle of the people, and it creates also gaps and disturbance into the living, the way of living. So another issue which is critical is that many of the ready-made, nice, smart solutions are very expensive. It's not cost-effective. It's not affordable for the people. So because most of the time the people will have to pay for their home structure, they will rebuild badly, and it creates a new vulnerabilities. Oops. Other issues, and I think it's more related to Turkey. When the earthquakes, I mean, this disaster happened in some rural areas or deserts or semi-desertic areas or mountains, it's a lot of there are many issues about the idea of people will mutate to the cities because they do not have a perspective of rebuilding again in the same place, and there is a tendency of the people, of the population, to fly away. I mean, to flee away and go to the suburban parts or to the cities, which is not good for the urban planning and urban management. And of course, it creates family divide and economic divide in some region. So the social or low-cost housing is not easy to plan, and rural families do not accept these standards because they are used, for instance, to single houses and not multi-story building, and it's a great gap, and it's a break. It's in the life of those families. So local or traditional technologies are sometimes being abandoned because of the bad reputation that they have, and also because nobody is able to implement them properly. So the quality of the know-how is being lost, and it's also a challenge to see whether how to make the decision between a local and available technology against new technologies like standards or imported or prefab construction. So there's always a discussion to what is the best solution in a specific context. So, having said that, we also found out that there's some kind of technical insecurity, which means that a lot of people think that they build, but they don't know how to build. Typically, a mason, when he's not trained, he will mix the powder, the cement with water, and magic will operate. And he thinks that it's strong because he cannot push it or crush it with a hammer. But of course, it has nothing to do with an earthquake. And he wouldn't know the basics of reinforced concrete and where to put the iron, even though you have seen it from some time, but they are not properly educated. And what we call informal education is sometimes can be very harmful because they duplicate, they replicate things without knowing what it means. And so they sometimes, what we witnessed, for instance, in Haiti, we were working there a lot. We were used to say that the people were used to build their own grave before because what if you see it properly, they don't follow any rules, and unfortunately when they build their house, they build their own grave. And it's very sad because people put a lot of money. Cement is not a very cheap material, and they spend a lot of money in something which is very poor in terms of structure and very dangerous. So there's a great attention to be given to that kind of insecurity that is provided by the people themselves. So we also found out, of course, that, and this is very accurate for Turkey, besides being a very advanced country with very good expertise and regulation and seismic background for decades, we know perfectly that many buildings collapse because they did not follow the regulation. So it's not a question of having regulation, it's a question of application of regulation, enforcement of regulation, and control whenever a contractor is delivering a building. There's no post construction assessment or some corruption, whatever. And of course, this creates a lot of damages because when we talk about multi-story building or location where it's not safe to build, and that was the consequence when I remember in Izmit 15 years back, 20 years back, there was this liquefaction of the terrain and so on, which was obviously not a place to be built, and there were many buildings there, and of course all the building collapsed at once and very, very badly. So that's something that could be avoided. And what's a new challenge today is that, of course, not only the habitats needs to be strong, but they need to be properly designed to fight against the weather conditions. And of course, the climate change effect is very, very in front of us. We are still building in these countries today, not in emergency, but I will share you some images later on. But the conditions of heat, of weather, of winds, hard winds, or flooding, or submersion by the sea, is actually increasing. And most of the time, of course, when there are reconstruction projects, the sites are not good enough. And nobody pays attention to that kind of risk, which tends to be higher and higher in the next coming years. So, and another issue which also fits to the Turkish context is the problem of energy. We realized that some of the projects we had done or we had witnessed in Nepal or in mountain regions is that people are not cannot afford to have fuel for heating their house or for cooking, and no access to wood, or it's harmful to the environment to cut woods because afterwards there's no forest and there's no agriculture and so on and so forth. So the energy consumption of buildings is very important. It's not only that you put a shelter to people, a roof and walls, but you have to understand how the people can run and can live in the house when it's cold or when it's rainy, when it's raining a lot. So what is the aim of so having said that, there's no magic again, and there's no miracle, and it's a long way to understand what can be done, and each of the disasters or each of the context is new, and we have to kind of rethink again the strategies and the approach and the methodology for choosing the best technology, but not only the technology, but the overall approach to deliver some appropriate habitat. So talking about alternative technology has to come through a series of questions, and it's not all of the questions, but at least some of the questions. What is the purpose of alternative technology? Alternative technology is a response to bad housing, energy insecurity that I just mentioned, and climate hazards. And this is actually the basics of what we would call a decent housing. I mean, right to a decent housing for all, which means wherever you come from, which country, which ethnical background you have, or are you rich or poor, you should live in good conditions, at least human conditions. So technology has to address those issues, and also an alternative technology is something that you can source locally. You can definitely map properly, or you have a knowledge. Today it's quite easy to access to information or to deal with people who have information, like universities, like local administration, like people association, and so on, that can tell you, or only by looking at the local buildings or the recent building that were built something like 50 years ago, for instance, you will find out that there are many technologies that already are available, that have been lost, forgotten, and can be revived. So another issue of quality of alternative technology, it has to be cost effective. I mean, if we're talking about the most vulnerable population, can be rich people who have lost their house or poor people that will remain poor. Both cases, they don't have money and capacity to rebuild the same house, and they will probably take many years to rebuild again. And so they will need to pay attention to what is the cost, what is it cost effective, and avoid bad practices. I mentioned that already. Bad practices meaning bad construction, bad or false or fake construction that is not good enough for addressing climate hazards, for example, or earthquakes or storms or this kind of thing. So to summarize what I've said, alternative technology is something that deals with mid-term and long-term development, something that can be, as we say today, resilient, which means that in case of a problem, the technology can be retrofitted, the house can be retrofitted, we can repair, we can reorganize the house, we can go back to a safer stage of the house, and without spending too much money and without having too much damages or victims when something strong happens. So the technology has to be kind of retrofitting by itself, can be retrofitted by itself with local people, with not external, as less as possible external help from outside, which was not available. When you have a disaster, you have lots of international solidarity and money coming from the governments or international organization at the beginning. After 1 or 2 years, or even after 6 months in Turkey, I don't know if there's so many money available today. So that's also a reason why we should also go for technology to make sure that the house delivered can be properly managed and maintained for a long term without much effort. So let's go to the core issue of one of alternative technologies that we have experimented for the last 15 years. So we call it confined stone technology. and not gabions, because for a very simple reason. It's the same, huh? for sure, but we call it confined stone wall because gabion is the technical word for public works. I mean, usually you use the gabions for retaining walls in the mountains or in some kind of dams or some. So that's it's a we call it un mur poids en français. It's I think it's a weight wall. I mean, it uses the weight of its structure to withstand, to retain the forces that comes from a slope in the mountains. So it's a static definition of what a gabion can do is to stop the force that avoids to the slope or a part of a mountain to slip over. And so with its strong and the heavy load, it's a load wall. I think it's not weight. It's a load wall. The load makes the strength, but it's not, of course, active. It's not dynamic, which says it's not standing against an earthquake. So what is the difference between a gabion and the confined stone wall is that the physical property of the cages of wire mesh, the iron mesh that you see in the middle, and the stone that you put in the cages, it has new properties if it's done properly. But it's almost a gabion, but it's not exactly a gabion. But the property is that the physical property of during an earthquake is that the stone will stay, of course, confined. I mean, kept into the box, okay, but it will physically shake. The stone will physically shake between each other and dissipate heat. Technically, when the stones will move during an earthquake, the energy they are going to move, and they are going also to create energy. So one energy of the earthquake, the strength will not go down directly to the soil. It will take some time because the stones are moving, and then the energy dissipates until it goes back to it goes down, and at the same time it creates friction between the stones, and it dissipates a portion, some percentage of the whole energy given by the earthquake. It escapes through this friction, which is technically heat. So the technology is very simple. It seems very simple, but as far as seismic resistance is concerned, it's not at all simple. What I just tried to explain very simply is not at all documented scientifically. It's a very puzzling, but it's true. Nobody today, I really say it, nobody today is able to modelize properly how a bearing wall, because we are talking about bearing wall to put people in it, to build houses. Nobody knows exactly how to modelize technically and mathematically the behavior of this system, because of course it's not like a brick or a cement block. It's not a unit. So the modeling, I would say that for those who knows a bit about engineering, finite elements, the modeling of finite elements that you put on computers, we've done that. I'll show you some images. Is not proper. The model doesn't work because the deformation, the way the structure will react to different axes of dynamics, of the three axes on one earthquake, and the worst one being the vertical one, which is very bad for any construction. It doesn't work. It doesn't explain properly how we can we cannot anticipate how the building will deform properly and not break, because the idea is that the building is deforming itself, but it's not breaking. The important thing in earthquake design, in architecture, is not that the building will not collapse. It helps the building to stand by the time people from the building can escape the building. The seismic engineering in architecture is not saving the building, is saving people who are in the building. Okay, so that's very important to understand. So the idea came from Pakistan in 2005. We were far away in the mountains where after an earthquake that took place in Patagon region that was very remote and very unsafe in terms of security, because there were almost a war there. And there was no access. Logistics was very poor. There was no material affordable. Cement and iron was very, very expensive, and no roads. Only the donkeys would come and so on. So we said what to do, and we realized that the people were traditionally building their homes with stone. I mean limestone, and they were having some kind of reinforcement a reinforcement for earthquake, but not really. And we said, okay, there are a huge amount of already material that some stones were available, and of course many of the houses were collapsed, but the roof were very heavy with earth. So of course the weight, the load of the roof would have collapsed and put down the structures. So we said that there was something to be done with earthquake. Unfortunately, the gabion, that some engineers of us said, okay, why don't we use the gabion technique to rebuild some houses? And that's how came the idea. Unfortunately, we could not do anything there because we were forced to quit. We were working at that time with the Red Cross, and we had to quit the camp because we were attacked by the local people, by not the local army or whatever. So we had to leave Pakistan. But we kept the idea, and since then we have been able to implement experiment and made some construction and prototypes in various countries. Sometimes after earthquakes in Morocco, there was one earthquake and of course in Haiti, which was a major earthquake. In Morocco again, but it was not. It was a research and development project. In Nepal, the last and recent one that we did was in Nepal, and we are doing already today a prototype in Martinique, and we are doing some non-post-disaster but some housing project, normal housing, with this technology in Senegal. We're just starting now this year. Okay, so again, the principle is stone, wire mesh. We make cages with that. We put them together, and we put plaster inside and outside to keep insulation and to avoid any problems of whatever. And we do have a kind of house, and of course, all the houses are locally adapted to the context and made with as much as possible with material. This one is in Nepal, and of course we keep the typology. We keep what we call vernacular architecture, where the people are used to live in the same. So if you don't know that this is stone, the people would think that it's a mud house or earth houses, and most of the time we were working in those regions where people live in mud house. Of course, mud houses are not quake resistant. This one is quake resistant. So the principle in terms of concept design, as I said earlier, it's not only the technology, it's the geometry and the way all of these combine together. The form, the shape, and the way the forces during an earthquake will react with the principle of earthquake engineering. So to be very straightforward and simple, we have experienced many designs. It's always one-story building. We never came to a second-story building. We think that it's because we are not yet able to qualify this technology through the norms and standards, even including the seismic standards, because they don't know those technologies. The problem is that they don't know. They would use the RCC, I mean the reinforced concrete systems, to modelize, and it doesn't work. So it's not safe to say, even though you go through this screening with software that will calculate the behavior, it doesn't work. So we don't want to take any risk. So we said we are not going to do any multi-story building. We do go for only one-story building. And sometimes in Haiti, for instance, we made half a a story. We made half the basement, half of it, I mean, up to 1.5 meters, were in gabion in CSW, and the superstructure under the roof was with wooden structure. I mean, with braced, so that it becomes seismic resistant. But also in Haiti, we had a problem of cyclone, which is a reverse, which is the roof is uplift. And so we need to pay attention, either shaking the box and also avoiding the roof to be taken out with the depression. So it's a double problem for design. But basically, what you need to keep in mind is that it's a whole. So you have a box. Basically, the more it's a square or a very strong, very sharp, dense rectangle, the better it is. Okay, you have to be very symmetric, not so many openings, not so many doors and windows, and you have to be very simple frame. Of course, the best would be a circle, but of course we know that circles are not very good for living, because we cannot put furniture, and it's not so. We keep to a square, but the main thing is to put the diaphragm, which whatever it is. So either it's only reinforcement in the corners. In the Haitian case, because it was a wooden structure, so a wooden structure will deform again and will share the forces to the corners, and it will go down easily and will not be broken. But it could be also slabs. It could be also joist with wooden joist with wooden floor. It can be whatever, as far as it plays the role of stability of a top wall, because I don't know if you see my mouse. On the top wall is the weakest part of the structure when it shakes, of course. So we need to have some kind of reinforcement which crosses the forces laterally from both sides as a plane, and that will help the box not to break. That's the main principle. So basically, then what is interesting is that there's no. So it's. I was talking earlier. It's a bearing wall. It's not. There's no what we see everywhere today, including in Turkey. We don't have posts and joists. We don't have columns and joists. We have a bearing wall. So it's a long continuous wall, which is 40 or 50 centimeters thick, which is which is very large, but it's bearing itself, and it's bearing the structure. So there's no foundation. The foundation itself is the gabion structure, because it's very stable, actually, because of the thickness of the wall, which is 50 centimeters. The load on the soil is very spread, and so the soil is easy to stand. I mean, we can build these in swamps or into the water itself, almost from out of calculation. So we build line by line, row by row. We put the rows, and we build up the structure, and then we put either a flat roof or pitched roof, whatever, and that depends of the typology of the way people live there. But the idea again is not to have a second story, but it's possible if you do not use the same technology. You can make a very light. If you put a lighter structure on it, like a wood structure, it's absolutely possible to make a double-story building. So the principle schematic of the making of the wall is not to have boxes itself. Actually, it's a U frame, and then it's a top and a cover, and we do put them all together in line, and we have rows of, let's say, 50 centimeters high, and we need 5 to 6 rows to go up to 3 meters, which is the average of height of a building. What stone, and this is becoming interesting, can be any stone. That is the beauty of this technology. Even those stones, I don't know how to call it in English, galets, round stones, like the river stones, they seem to be okay, but it's not as okay for seismic resistance, because they do not have enough friction points between themselves. So it's less quality than the others below, who are actually like hazardous form, and it can be any kind of stone, because unless you what is required is that you use the same kind of size, roughly. But if you have big stones, you cut them into two, and then you put in like this. You don't need to cut them properly. You just use stones. So what do we do usually? We collect stones around the places. In Haiti, we were not working in the city itself. We could not. So we were working in the mountains with rocks. And so people would collect thousands of stones. We need something like 30 square meters, cubic meters, sorry, 30 cubic meters to build a house in Haiti, the Haitian design, which is a lot actually. But they have time, and it's free. It's free, of course. We just collect it, we put it in somewhere, and then we use it to fill the cages. So, and of course, what is interesting, and that might be interesting for you to consider in Turkey, we never did that yet, including in Haiti, because it was difficult for some other reason, access to the rubble, to the houses destroyed. Our idea was to reuse the destroyed houses, finishing to put them into rubble, into small stones, and then put it back in the cages to rebuild again on the site without transporting anything to rebuild the houses. We could not operate that because of problems of timing and access to some location which were very difficult in Port-au-Prince, and but we still have that in mind, and that's some research that we would like to explore. So the steel wire, we use it. We don't buy mesh. We do it ourselves. Why? It's cheaper. It's easy to do. It gives power. It gives jobs to local people. You can pay them, and you produce your own material to do the cages. So you buy this in bulk. I mean, and often it comes from China or Turkey. By the way, the iron is steel is very Turkish of origin, and we buy it. It's easy to manipulate for people, and and to transport on location on site. And we do open a small workshop on site where we build. So I'll show you some images. So we have a workshop where we do knit, like knitting, like we do knit the cages, and they're available directly on site to be filled with a stone. So we prepare the stones. It can be different. We have some machines sometimes, or we do that with handmade like nails, and it's very simple technology. But we do open workshops, and we provide work to people, including women, for instance, because it's an easy work and it's safe. And we train them a bit. We train them for 1 or 2 days, and then they can produce. So we were able to set up a cooperative kind of income generation program in Haiti, where they would produce and sell back their product to the project to make some money. So then we do have some specific tools or machines which are very hand machines to fold and to prepare the cages to make it properly with the right dimension and the right angles. It's very simple. We then start the construction. Oops, sorry. I don't know if it comes. Okay, so I said no foundation. We do not have foundations. I mean, the thickness and the width of first row is good enough to play the roles. Okay, so it's very easy. You just need to dig up to the good terrain, the good earth. Of course, no organic earth, and then you can build. You can start to build. So we can build in very diverse contexts. Up. So we start to put the cages one on top of each other. It's going by line. Of course, there's some framework which also to make sure that it's very vertical and horizontal. But it's quite easy to So the training comes here. We need to train the people, local masons, but there's no cement at all. Huh? There's no cement at all. We just put the stones like this. Those seems to be a little organized because the stone that we are using had flat faces, but that's the only thing. Usually they're not flat at all, and you don't need to do it because again, it's going to be plastered after some time. So you see the cages, you see the details, because of course there's some reinforcement between the cages, so to avoid the wall to become fat. So we need to put some tires of iron just to avoid the wall to become fat. Then we need to put the frames, the window frames, the door frames, which are inserted into the wall without again any cement, any sealing. It goes like this because with all the structure and all the load of the cages, it stands, and then of course the windows will be put inside. This is very basic, of course, construction, but it's very. It was very, how do you say, very relevant to the local construction, and very much alike. And nobody was complaining about this is so different and so on. So except seeing the cages in steel, I mean, you wouldn't make any difference. I mean, the typology remains the same, and then you see some details about the frames where to put the windows, and then you see some wooden guides to make sure that the walls are vertical and on line. And then you see different ways of doing the ceiling. So this is a classroom. The classroom needed to have a very the spanning was like 4 meters. And so we decided to make a special truss for that. We do use also some local material for reinforcement. In this case, you see there's no flooring. There's only one reinforcement by the corners. And it gives a structure which is ready to be plastered. And we come to it and we go a little. So sometimes we have wood, and we do seismic resistant trusses and carpentry work. But also you will see with locally, this is seismic reinforcement, but this is really locally made with plywood and nails, but it works. Huh? So it's 3 dimensions, and it is design. It's not like it's not cheap design. It is design and engineered. You see some kind of assemblies there, which seems to be very simple, but which are very calculated. And this is a low cost. Locally, this is wood taken from the palm trees in Morocco. We recycle the palm trees, which are very bad quality for construction, but for the sake of the construction, it's okay. And you have a roof with a mud plaster on it, so for insulation purpose. And you see here some detail, for instance, in the back, in the left, the right side of the picture. That is a very critical point, which is the end of the roof, and this also is calculated. Some options where you put some iron sheets for waterproofing or not. It depends what you want to do. So you keep the shape of a very typical Moroccan style with no roof, flat roof, and we do have some iron sheet to preserve from the rains. Again, you see how we can the finishes. So it's not only finishing; it's also giving quality, insulation, and safety to the house, and also kind of protecting the wire, the steel. it's stainless steel, but still stainless is not stainless, as you know. After some time, the steel may have problems of rust. So we are always covering the structure with plaster and mud at the beginning, because there are many holes. And for the first layer is plaster, and then first coat is a plaster and straw sometime, and then a thinner coat of earth, and then we make a mix. The finishing is a mix of plaster with clay, with clay or lime or sand, whatever we find locally, to make it stronger and to resist from the mechanic erosion, like the winds or the heavy rains, so that the plaster is strong. So, question what we had in Nepal is how can we, are the population able to do it themselves? So can it be self-help construction, or can it be, as we say, owner-driven, meaning can the people build themselves or organize themselves to build and participate, contribute to the construction? Maybe not as manpower, but also as a designer or monitoring. So that's typically the kind of added value that we bring as an NGO as compared to a contractor or to a private firm, because we think that we can push forward the building codes, the test, we do a demonstration units within the university to convince the local people, the engineering staff, that it's possible to build these non-traditional or non-academic or fancy technologies. An example of a demo house that we made in Nepal to showcase how it can be built. So we tried to put this into the building code. Didn't work, but we were a little disappointed. But we tried to comply to all the technical description, but the description given by the Ministry of Construction was not compliable with this kind of alternative technology. This is a problem that we have. Some figures, I'll give you a presentation anyway. It's some figures that says how many kilometers of mesh you use, what is the weight of one cage, and so on and so forth. So you see, when you do the calculation, you see that you use 250 kilos of kgs of iron, galvanized iron, which is not a lot as compared to reinforced cement. So of course it's not a perfect solution, because there's always a disadvantage and advantages in one solution, but it's interesting to have some comparison as regard to others. And of course the cost, maybe those costs has nothing to, won't tell you anything in Turkey, but we are very far from the current, we are something like 10 times less than traditional construction. That's the main figure that we have in mind. So of course it's very attractive, but of course a lot of this money is because there's some volunteering work, and there's some savings that are made from collecting for free the material. For instance, the stones are free of cost. If you find it around, it's free of cost. What is expensive is transportation. If you go for, so these are a few examples of what we built. So we put this to show that this building is made of gabions. Otherwise, people would not understand and would not trust us that there's stone like this inside, because it looks like the mud and the plastering that they use locally in the villages. This is a school in the desert in Morocco. This is a house in Haiti with the basement, which is in of gabion, and the rest is a wooden structure with filling with stone and cement and mesh, but not gabions. This is a demo house in Morocco, done with an agency for energy efficiency in Morocco. So what is stressed? It's a dry technique. What we call dry is no water, no cement. So you don't need tools. You don't need a crane. You need only a hammer and some scissors, and that's it. You can go with unskilled labor. You can train people easily. and you can reduce a lot of the technology is very strong. If you cannot make mistakes, I mean, this is also the beauty of it. It's modular. Sorry, it's going too fast. Okay, so it's flexible. It has it can have many layouts. Of course, it has limitation, but there's a diversity and it respects local architecture. It can be built in very remote areas as well. Up, I'm going a little faster because I think it's over. We can modulate. It's a modular plan. We can make several units, and then in between you can make buffer zones with light structure that can save construction. So if with a little smart and thinking, you can really build interesting structure without building everything. And it's as I said earlier, it's the people themselves can build on their own. There is income generation. There's people do participate and benefit from the reconstruction. Can create some economics as well, and the community is self-help. The community can help. They can one family can help to another to build the house, and this kind of setup. In terms of performance, of course, there's a nice interest in terms of CO2 emissions. It's very low and gray energy. It has some thermal insulation. Depending the climate, but usually it's quite interesting because it avoids the heat during the day and it preserves the cool during the night. And passive house, it's a passive house in a sense. There's no need, and this is the principle of shaking. The normal wall will collapse after some time of strength, of constraint, whereas a Gabion wall will not. It may deform, but it will never collapse. That's the truth. So how do we know that? We made some modelization on finite element with some very high range software in France in a lab in a university of Rennes, and this was done 15 years back. And this is where we see the weaknesses of the walls and so depending the openings and so on and so forth. We made some calculation. We made also research with a shaking table in Sicily. I know that in Turkey you have also shaking tables for seismic construction. So we did one campaign in Sicilia, which is not over, but we shaked a test wall on a very high acceleration of replicating the worst earthquakes. Of course, this is only one piece of wall, and as I explained earlier, it doesn't work on only one piece. It works, but not enough, because it's not only the technology of the piece which works, it's the geometry, it's the architecture. As I said, the box plus the diaphragm. So, but this was relatively successful, and so we are still documenting, and we are still on process to find money to continue the research. And this is the project we have in Senegal. When this time we have a story, but the story is not with Gabion, and unless there's a small wall, the story goes a little bit up to the second story, but then the upper floor is a steel gauge structure which is also seismic proof, but will move differently from the bottom. And then it is also seismic. It could be seismic resistant, but the good thing in Senegal is there's no earthquakes. So, but we do implement, and we do have the same project in Martinique, this time in the Caribbean, French Caribbean, where we do a prototype with a specification that we are currently trying to put with French regulations. This time we are going to certificate the technology through a specific process with the French administration. I think I'm done. Sorry, I was a little late according to my schedule, but that's it. Thank you.
Thanks a lot, Ludovic. Yes, you were a little late about what you said, but it was not too long for us, so that's perfect. Was really happy to hear, and especially that you started not directly on the technical part of it, but the background about what are alternative material, alternative construction techniques, exactly what we are working on in this association, and but to remind us the aim also of them, not only as we do here, speaking about ecology or sustainability of the materials or health for the people, but also affordability, but also ease to use. So that was really good to remind.
Sorry.
Us.
This is the test that we made in the. Can you hear me?
Yeah, sure.
Okay, sorry. So you see, it's shaking a lot. Huh? So I don't remember what was the limit, but so the thing is that it didn't collapse, but it should not collapse or no break at all. See, that was a very good test for us. Sorry.
No problem. That's good to see that those tests are happening, because that's how people discover the quality of the work. So thanks for sharing also this video. So yeah, I was really happy to hear about this. And before I start with two questions I have, because I was really happy to hear it, and I have some questions, of course, like usual. I would like to ask in the audience, is anyone has question or not? I saw that someone wrote in the chat. But anyone else would have questions about what we have listened?
I hope it was clear. Huh?
It was really clear. I mean,
okay.
According to me, it was really clear.
I had a question.
Yes, Mary.
By the way, I wrote wrongly. I think my question was, the walls start from the foundation. Normally, you're starting from the foundation.
Yeah, as we say, there's no foundation because it's a bearing wall, and the wall itself is a foundation. I mean, the first layer is actually playing the role of a foundation. So you just need to dig, of course, horizontally to a certain deep depth, so that you of course, for some reason, but there's no specific foundation. You don't need to make a cement foundation. I mean, the wall is bearing itself on the earth.
Do you need any drainage around?
Yes, of course. I mean, the rest is. I mean, it's a very good question, actually. But depending where you build, you have to pay attention to the local drainage and the rainfall, and also the rainfall, the drop off coming from the upper mountain, for instance. But typically, what you would do is that you would have a level, different levels. So we engrave, we put the foundation layer down something like 50 centimeters, and then, or it can be a little deeper. And then the first layer, which goes outside, is actually different from the earth outside. And of course, the soil in the plinth wall, the plinth in the house is higher, so that there's no problem of water coming in. But in terms of water coming through the structure, that could be a problem. Usually we don't put anything, but you could definitely put some plastic foil or whatsoever to avoid, or definitely you need to dig caniveau, je sais pas comment, j'ai oublié comment ça se dit, some drainage outside for water, and of course you put gutters from the roof to avoid the water to split at the foot of the house. Otherwise, like any house, you would have problems. But we never up today, Senegal will be some high standards. Up today, we've been building on very rural context with very basic, but there was no such standards. But definitely, yes, some drainage is a must. You need to do that.
Okay, thank you, Ludovic. There is a question from Fulia, I see. Yes, please.
Hello, thank you for the presentation. I want to ask two questions. Do you have any publications that we can see that the details of this works? And another question, are there any possibility to adapt this system that you do with cage to the existing stone buildings?
Okay. So first question is easy. Yes, we do have a publication. I can share some of those. It's not like, as I said earlier, a public or pure technical or academic publication, but we do have some details that can be useful for you. We do have some reports, and I can share you a video of the construction as well, what shows in a 3 minutes video the way it works. But yes, we do have some publication to share, no problem. Second question, I'm not sure I understood properly, but you want to put the cages on existing structure? Is that your question? For retrofitting or for reinforcement? Is it your question?
Yes. Okay. Can we reinforce the existing stone buildings with these cages?
No. This is not the, no, this is, I mean, yes and no, but no, the construction is a full-fledged technology. It needs to be built from scratch, and then you build like a Lego kind of a thing. It's not a Lego, but it could be like a Lego thing. So you need to build the cage with and fill it with stone. So of course you will see in the video I'll share with you. You don't prepare the box and then you don't move the box with a crane to put on the wall. You prepare the box empty and then you fill it by hand with stones. Okay, so you cannot. So talking about an existing structure, you will have a problem because you cannot make a cage in an existing structure unless you dig holes through the wall, so it doesn't work. But what we tried to do, and again in Nepal, it was a multi-technological program that we had. We had new structures, so this is for new structures, new housing. But we also had a retrofitting program where the people used to build the traditional chalet, mountain houses with stone, but dry stone with no cement or hardly cement. And there was a big problem of shaking, and the structure were not standing against the earthquake. Again, the know-how of this local traditional people were lost, and the history shows that in the previous earthquakes, the people were not surviving. I mean, they were dying. There's a myth sometimes that the old people would know how to build, but no, they were dying also. Some of them were surviving, some of them not. Some houses were standing, some others were not. But in the overall, the technology is not purely scientific and is not 100% safe. So what we did is we did some assessment. We had a very good partnership with a foundation of a big company, French engineering company, that sent for free 1 week people. I mean, they were giving 1 week holidays to their engineers, structural engineers from France, and we had something like 50 people. We had campaigns of assessments, technical assessment, very high levels of assessment done by engineers on local small structures in the village, very far in the Nepal. And then we were able to understand where the houses, the structure were weak, and where we could retrofit them instead of demolishing everything. the Nepalese government said, okay, we are going to demolish everything and rebuild from scratch. Of course, it's not possible, too expensive, and it never happened. So we said, no, we are going to make assessments, bring technology assessment, and then we can retrofit. What we propose is that we could put gabions on the existing structure, but on touching in the corners most of the time, and then we would have tensile iron from one end to another to make some kind of reinforcement. But we did that as a test, and we didn't have time or money to duplicate, but we did try to use the gabion walls more like a reinforcement from the outside, but not for the existing structure. It's not possible. I mean, to my opinion, it's not possible, unfortunately. What is possible is to put some mesh including cement structures, and then to do this reinforcement that we can see sometime. I think you're using that also in Turkey. You can retrofit some heritage building and this kind of thing with putting some reinforcement mesh where you put cement. So it gives like a bandage to the house, but it's a tricky solution. It needs to be very well designed and calculated, which is not at all easy. Retrofitting in seismic condition is very, very difficult.
Okay, thanks a lot, Ludovic, for this answer. I don't know if Fulya is totally answered your question, or you would like to add something?
No, thank you so much for the answer.
Okay, thanks a lot. Is there anyone else?
I would ask a bit about your organization, A&D. Is it, as I understand, it's also working like a cooperative? Normally, the association also make houses, but making houses with the foundation, so you're not selling the houses, as I understand. However, you're working with designers and builders for projects. You're making projects, housing projects, as I understand. No?
No. I mean, I wish it was fully true what you said. I mean, unfortunately, we are not able to become contractors or developers, because it's another challenge, and we are not able to do that anymore. No, it's to be clear. All the work we did in post-disaster reconstruction, of course, was funded not by us. We don't have money, but funded by foundation, as you rightly said. So we had partnership with big foundations, because we are very few, including in France, to be specialized as architect in reconstruction. Most of our construction, until we decided to found this 25 years back, was done by the big Médecins Sans Frontières, Action contre la faim, all the names that you would know in their English names or Turkish names. But Architects Without Borders, this kind of thing. But most of the time, the money comes from the big donor agencies. So it can be private foundations. It can be the Red Cross itself, who is also implementing, but also giving money. So we did partnerships with Médecins du Monde, Médecins Sans Frontières, Croix-Rouge, to implement for them some the building program of their reconstruction program, which deals with health or education, or sometimes. So if it's health, we build a hospital. If it's education, we build schools. And they do, and the rest of the NGO does the teaching and so on. So we did the hardware thing. So always, and including with housing, of course, in that case, the foundation pays for the housing. So the victims are not paying for their house, for sure. Okay, it's a donation. But of course, it's small figures. We built hardly up to 100 units. Each program for us, 100 units is quite a lot. In India, it was huge numbers, huge figures. Thousands and thousands of people were missing, and we could not, of course, building for thousands of units. It's not our scale. It's out of scale for us. So we are not builders. We do not want to become builders, but what we do today in Senegal is we help housing cooperatives to organize themselves and so they pay for their house, but we use this technology to reduce the cost, and we play the role of a developer for free, and we get subsidies from the French government for the sake of low carbon houses, or climate change and so on. There's a lot of money, and this is the reason of an NGO. We take the money from government or international funds, and we do translate this money for the neediest people, and we pay ourselves on this with this money given by governments. And of course, the beneficiaries never pay for us. Of course, we could not afford, and we need to pay people. Although we have volunteers, it's difficult to find, and we do want to do professional work. So we are not sending trainees or interns or for free of cost. No way. It's not possible for us. We are following some charter and ethics. So there's no option for that. So what we plan to do for the first time in Senegal is to support the cooperative movement in Senegal. There are thousands of cooperatives, and we help them to be able to become developers. So that's another work. It's a new work for us, a new challenge, and we provide the whole thing. We do help them to access to the banks, to credit, to organize themselves, and then we do provide the design. We are not the local architect. We have a partner. We are never the local architects. We are not allowed. We are an NGO. We are not a firm, and we do not want to take the responsibility. So we do always have a local partnership. We follow the regulation. We do submit building permits and so on. It's not at all, fancy work, or because it's a solidarity or humanitarian work, it would be like no regulation. No, we do want to make it normal, and we do also advocate to the local authorities, to the administration. So that's very important.
Yeah, you are controlling afterwards, or you're giving this control mission?
Well, usually what happens is that we do stay during the construction, and we do, because it's self-help construction, it's a contribution of the people themselves. So we hire some local firms sometimes, but we do control. So there's I appreciate your question, because it's a very tricky question, but it's a real question. The responsibility in case of a collapse of one house, and in case of some problems, who is responsible? Unfortunately, in the humanitarian sector, nobody is responsible. Once you've done your work, the people go back, the big organization leave the country, and then people are left alone. So problem is that to avoid this, we do go through local architects or local engineers to secure the drawings. But as you know, and it's always the same problem, there's no insurance, there's no if you want to go for an insurance, it costs the double or 10 times the cost of the house you're building. So you do efforts to downsize or to reduce the cost, and then you will pay some huge amount to a company, a global company who will make money out of it. So it doesn't work. So that's a problem. Yeah. That's a limitation of the work.
Thank you very much.
Thank you, Ludovic. In the chat, we have a related question about this.
Okay.
Step, how to find the fundings for being able, for example, to build those kind of buildings in Turkey, because as you said, it could be an interesting technique to use. So some setup is asking about it.
Yes. How do we find the funds? Huh? That's what I'm reading.
Yeah.
Well, we find it, but it's very difficult. I used to say that being an architect, I don't have my own practice. I never had. It's actually my practice is through the NGO. So we do not earn our money with that. Of course, we do not have fees We do pay some cost and cover sometimes, but so what we do is we design projects. I mean, projects in terms not architectural. We design development project to donor agencies. So donor agencies are banks, development banks like the World. I'm saying World Bank, but it's not the World Bank because World Bank doesn't fund NGOs directly. But there are many agencies, development agencies, what they are called, where you can submit proposals to with the objective of reconstruction, with helping people to against hunger, against climate change, and so on. So we do design these programs, which usually are not only construction, of course, we are training, and we do make partnerships with other NGOs to submit proposals and get the money. So this is where, and this is donations, this is subsidies. Huh? It's not a contract. So we do not apply to call for bidding. We do not bid at all. We make only submissions of projects to the European Union, for instance, will be a good agencies to target. But there are many others, including foundations. We used to work a lot with Fondation de France. I don't know if it's, Matthieu, you will know what it is, but the Turkish people, I don't know. So there are many foundations who have some specialities. You know, sometimes they go for the children, sometimes they go for, I don't know, health or nature. So, for instance, you can find money to foundations who want to promote wood or to promote bamboo or to promote this kind of stuff. So it's a question. It's a job, huh? Fundraising is a job. We do have this experience for after some time, of course, and of course we have now a little network, very small but enough to make projects. So this is, for instance, the project we have in Senegal is a special fund from the government of France, which is dedicated on environmental. Is a subsidiary of the Global Environmental Fund, the GEF, the fund who is where all the states contribute to make some projects against climate change and reforestation, this kind of thing. So France has one such a fund for itself, and it makes call for ideas, and we respond. We do design, write proposal, and we collect money. So usually what they do is they fund half of it, half of the money you expect, but it can go to 1 million euros, for instance. So you can do things. This is typically the one we have. It took us 2 years to get it. Huh? It's not like it's not because you know the people that you get the money. You need to provide the documentation and very strong capacity of writing a project proposal. But after 2 years, we managed to get some money. So it's worth doing. But as you may know, the NGO, association is a very benevolent pro bono work, but when it comes to get money, it's very successful, and we're happy to convert this money into projects. But it's there's no certainty. It's always a challenge.
Thanks a lot for it. And continuing on it, not only especially on this, but usage of gabion in Turkey. You were speaking about maybe rebels could be could be used, but we have this problem. I don't know exactly, but when we see all around buildings that are being destroyed, there is one good thing in Turkey is that a part of the deconstruction is they are taking out every reusable materials such as windows or doors or whatever, but still after there is all insulation material, asbestos, is if any, plaster, bricks and concrete is mixed and so on. So there would be a huge work of sorting the materials to be able to. Yeah.
But again, there's a lot of experience since I think Haiti made a very strong difference after some time, because there were billions of cubic meters. I think it was 6 billion of cubic meters estimated to be available in the Port-au-Prince capital city, and nobody knew what to do with it. It took them more than a year a year and a half to evacuate this rubble to the sea or to some compensation land and so on the sea, and it was absolutely ineffective in terms of cost. Of course, hundreds of thousands of trucks with the pollution and the cost that it represents, and big money for the guy who's renting the truck, of course. So this money was lost. It was nothing. It was not reinvested in the construction. So problem is the sorting and the material. So there were programs mostly undertaken by the UN, United Nations agencies. There are specialized UNOPS and UNDP. There are many agencies in the UN. Some of them are now specialized. Even the Red Cross did that. They were sorting the rubble, crashing. They were having machines to crash and smash the big bulk of the debris. In terms of and of course some iron in it, mixed from the insulation materials, so the mix of it. But they did that. There were programs you could apply and have some work and to do that. And then of course recycling some of the material for. So they never did that for housing, for sure. They did that for reconstructing roads and using it as, like layers under the roads and this kind of thing, which is quite good. Or paving. Some of them made some crushing. It's so little, and then they pressed it again with lime, and then they made this nice design pavements to make some pavement on roads. But it's time consuming, but it's good because it's, as we say, Ashimo, it's a high intensive labor. And it's for when it's reconstruction, it's very important that you give work to the people. They are jobless. And it's very good to design this. So the idea is that we never came through yet is to recycle this debris and put it back in the gabion. I think it's a question of it's a step-by-step approach. You cannot rebuild a multi-story building. That's for sure. But if you can build schools or social buildings that will remain, that do not need to have multi-stories, and then can be put on site, not far. 100 meters away from the collapsed building. That makes sense. And it's available, and it's possible to mobilize the population. The local people will contribute for free to build the new school, for instance. See, this kind of thing. So definitely there's a scope for that. The only thing you would need to do is to get the machines and so on. It's not a big deal. And even in Turkey, you're very well equipped with this machinery, and this building sector is very up level. But you would need to make some tests on the shaking table, because again, this is very important in Turkey, even though it's a basement building. You would need to make some tests on the shaking table to see what is how does it work in terms of reusing the debris. But it's very for me it's very possible. And again, because this is where the test we made 2 series of tests, and today we are going to make another one in Senegal with changing the kind of stones to see up to what kind. As my point was to say, whatever we put in the gabion, it works. This is what we would like to prove. So to what extent we can reuse even waste, you see? So why not? So it's only a question of having capacity. And I don't know what is your university doing, but if your university has some interest into that could be interesting. But mine, for sure, there's
maybe others.
Yeah, if it's something you want to explore, I would be happy to discuss that with you for sure.
Thanks a lot. Another question that was related to this, and this is because, as you know, that this confined stone wall, are getting fancy with architects now to make some kind of modern architecture, but not used as a load-bearing wall, just as decoration or whatever. Yes. My question was about the placement of the stone, because I have seen some walls that those gabions have collapsed because there was some missing part, or maybe the stone were not placed properly, or I don't know exactly what was the problem. So is it important how to place the stones inside the gabion, or attaching the different parts of the cage is the most important part?
As far as I know, and I'm curious whenever I see this kind of walls in everywhere. First of all, usually they're not bearing walls, for sure.
Yeah.
Why? Because it's not allowed. In Europe or Turkey, I guess, it's not allowed because there's no regulation. And we come again to the same problem. There's no regulation, so you're not allowed. So nobody will pay an insurance, and the Bureau de Control will not agree to validate your proposal. So whenever you see this kind of wall, it's a decorative wall. Okay. Yes. So for some reason, they have to do some thickness because otherwise it doesn't stand itself. It's not bearing. Second, you will see that it's not a normal mesh. It's a wired. It's welded. It's welded and it's square. Usually it's a square mesh. Because it's welded, it's very expensive. So these kind of walls are very expensive, and they are not bearing, and they want to look nice. So they pay attention to put nice stones and pre-cut stones, so that it would appear very nice, and there will not be any green or whatever animals are going to be inside. So why is it collapsing? I don't know, but it doesn't matter. I mean, to me, it's not the same. Doesn't matter for me. It's not what I would like to add, because yet it's still interesting. You find in the market not welded but wire mesh, which has plastic on it, and that could be interesting because and it's related to the question of drainage. We plan in Senegal to build in flooded areas. Of course, the ground floor would not be on the soil itself. It would be on the vide sanitaire. I don't know how to say that. An empty a void
above ground, a basement. I don't know.
It's the slab would be up to a void between the natural soil, so that there would be some. So the house would be floodable because the running water would go through under the basement without damaging, would go through the gabion, because it's of course there will be no plaster at the level of foundations. The water would flow, but will not damage the foundation, because the stone the water will not damage the gabion. And but the problem would be the wire mesh, the iron. So to avoid any rust after 20 years or 40 years, because this is calculated. I mean, the timeline of one gabion is 50 years. It's supposed to be 50 years, which is actually what is sold whenever you build a gabion wall in the mountains. The provider, I think there's a Turkish company who is doing that actually. They certificate that it lasts something like 50 years, but the thickness of the diameter of the wire is like 3-4 millimeters, which is very strong. It's difficult to bend it by hand. We use 2 millimeters to make the wire. So there's some specification, but definitely it's possible to adapt and to have options regarding the context.
Okay, thanks a lot. I don't know if there is more question. Yes, left up.
I think someone is. Yeah.
Okay, can you hear me now?
Yes.
That's fine. Very nice. It was very nice to hear that it's possible to build a simple and natural and low-cost building. And I hope also being able to find a fund is the most important thing, I think. and plus the bureaucracy, the rules of the building. But I hope we can get some cooperate with you or get some advice from you. Will it be possible?
Yes, I mean, as far as we have time for you, but on the principle, no problem, because it's one of our mission to support whatever initiative is coming through us. I mean, we do not look for a program, but whenever we are asked to do something, we can contribute sometime, of course. As I said, we worked in Turkey 20 years ago, but we lost many of the contacts, of course. But why not? I mean, and definitely. I mean, of course, when the earthquake took place recently, I mean, I was concerned. But we do not have capacity to do emergency work post reconstruction. But this is one, but because it requires a lot of logistic and some capacity that we don't have now for lack of people. But what we can do definitely is to think about more research and development projects or experiments or small scale projects with partnerships where we can adapt and do a Turkish project, which would have, of course, all the Turkish compliance to make sure that it works. As far as I understand, I saw many. I mean, I don't watch TV, so I didn't look much, but I think there are towns, cities which have been collapsed, but I think there's also rural villages. So definitely there's a mix between the urban context and the rural in the suburbs that could be interesting to catch the rubbles, for instance. I think the topic of the rubble reuse is a very exciting in terms of research and in terms of pushing forward alternative solutions. Because my concern with Turkey today, as usual, is that unfortunately, beside what any politician would say or any decision maker, this will not take place. The result after 1 or 2 years is that you will see that if you go to those villages, to those places, the majority of the population will not be rehoused properly. But it's not Turkey, it's everywhere. Don't worry. It's not. I'm not saying that against Turkey at all. It's always the same problem. So if you can help people to help themselves and to not depend too much on others, the better it is. But then so the need is huge. I mean, of course, there are thousands of families who need that. It's difficult.
So we'll have to somehow maybe find a way to train people and make a kind of chain of training.
Yes, I think many organizations. I think the Red Crescent in Turkey would be very happy to do that. And I know the network. I mean, of course, the Red Cross, the Red Crescent, and the Geneva Federation of Red Cross societies is very active, and they do have this kind of mindset. They know that they cannot build from new buildings and so on. So they are happy to. So we have former people who have worked with me who are now in those agencies. So they promote this kind of options. But why? I mean, if you don't ask, you will never have opportunity. So you better ask and then see what they say.
Exactly. And I think there has to be government in it. Otherwise, you can't do it. So somehow we have to find people in government who would actually think positively in this.
My experience.
I'll try in my way.
Yeah, my experience in Turkey was in Izmit, where we rebuilt a city hall. I mean, the Belediye of Izmit. It was with officials. I mean, I was working with officials in France. It was a very political connections whatsoever. I don't know. It doesn't matter for me as far as there's money and capacity. And we did rebuild with French funds, public funds, a public building in Turkey. So that's possible. It's possible.
So we have to, I think, discuss about it and find ways to sort out. Very nice to hear. Thanks for this.
Our association is also making now.
Yeah. That's what I was about to say. I think the civil society in Turkey is very active. I know the conditions and the political context is difficult, but it's always difficult. Anywhere, don't worry. There's no, working in Nepal, working in Haiti with insecurity and the corruption and the mafias and so on. It's not easy at all. So of course it's I mean, it's part of a job, huh? to be. You have to think positive.
The main objective is to.
Yeah, you have to think positive. Otherwise, you don't do anything.
The potential is that there people can also integrate to the construction. This is very, as you said, very exciting for us too.
And then the university, I think, there's a lot of capacity within the university in Turkey. There's a lot of capacity in the corporations, maybe the board of architects or the boards of planners. Why not? I mean, some of them, these institutions sometimes are very conservative, for sure, but sometimes you find people. There are always good people in bad organization. Let's put it like this. So you have to find the right person. It's important to have the right person. Yeah.
Right. Thank you very much, Ludovic.
You're welcome.
And hopefully we will contact you soon.
Okay, so thanks a lot. I think it was really good and enlightening presentation, especially this discussion on we can do it if we find the right person, and I'm sure everyone's will be looking for it. So thanks a lot, Ludovic. I think we can finish now. It's almost 2 hours that we are here.
Yeah,
together.
That's good.
So
that's
really, it was really good time, and I'm sure we all enjoyed it. So I can just wish you good luck for finishing all your projects and finding new funds for continuing this good job. And if we have any opportunity of working on this topic, of course, we will contact you, because as far as I know, you are one of the specialists with architecture and development on this topic. So
yeah, we are very few, at least, to work on this technology, but we do our best. Thank you for inviting me, and I will send you the presentation, and I have a short movie I'll send you as well.
Okay,
on a WeTransfer thing, because it's very heavy, but
I will share it with everyone after. Thanks a lot for it.
Okay, thanks again.
Thanks a lot. Have a good
night.
evening.
Thank you. Bye bye.
Thank you very much.
Bye bye.